We see the volcano in Iceland erupting, and we see the lava fall or watershed or whatever you call it forming and leading in outside of the crater out of the walls of the volcano. Then the question is where all this lava goes. Okay, the question is has several parts. Part of it, of course, we see comes over the walls of the crater spillage. You can see this color, brownish red, is a sign of oxidation. Also, some part of it go into this kind of holes here. You see these holes here. These are real holes. They are caves. And this is formed when the lava, which is in contact with the air, gets cold quicker than the lava which is inside the lava flow. So the outside gets cold, solidifies, the inside is yet molten and it stays fluid. So it moves. And the movement of it creates a tunnel, kind of tunnel. We call it a tube or lava tube, we call them. These lava tubes are conduits, are pipes, are tubes that guide the lava to wherever the deep of the ground is taking them. As you can see, we have now the eruption is starting, the 7 to 12 minute cycle they have. That's the periodicity of these eruptions. And as they fall down from the rim of the crater, the edge of the crater, outside walls of it, they come and sink into the different cavities that is formed by this process of solidification of the top part of the lava and the fluidity of the inside part of it, which creates these lava tubes. Let's watch this and see what will happen now. It may take a while that the whole eruption comes and takes over. So as you can see, now we have two streams running out of the crater. And they're carrying with them all kind of gases, including the steam. People ask how a steam can exist. Yeah, steam exists in minerals, biotite mica, which goes into subduction zones, accretion wedges, which is in the ocean floor, going back to the under subduction zone into the crater, into the subduction area, into the mantle. They create this kind of juicy, watery minerals. It's not fluid water, it's a water trapped in the crystalline structure. Because water molecules, if you know it, you have to know the chemistry. They are not negative. They are not neutral. They have a charge, electric charge, because oxygen is more electronegative than hydrogen. Toward the oxygen is more negative, toward the hydrogen is more positive. So they're kind of charged, and they can attach themselves to all kind of minerals who have a little bit charged, like salt, like olivine, all kind of minerals and metals and elements. The same with the sulfur. Sulfur is like oxygen, also has this kind of a structure. To a lesser degree, electronegativity of sulfur is slightly less than the electronegativity of the oxygen. So this is what we see here. All these kind of gases and steams you see coming out. That's one of the reasons the lava actually boils, as we see bubbles up, because these gases are expanding. And that is the way the atmosphere and the earth started. People who say that the lava and water, yes, of course, this is the way our atmosphere, our oceans were created. They said comets had a role in it, but I believe that comets had a secondary role in that. Earth already has a watery mantle, is full of water in the crystalline structure of the minerals and rocks. Look, where the lava is going to that cavity I showed you. That's the lava tube. That is the lava tube that I mentioned. Other lava goes down there. You can see there are more lava tubes here and there. You can see this eruption is almost finished now. And the next eruption will be between 7 to 12 minutes. And as you can see, these caves, these lava tubes are so huge practically devoured, swallowed all that lava coming out of it, out of the crater. I'll show you what's the volume of this. I'll put that clip again at the end of this video. As you can see, this is where the lava goes. Those holes you see there, they are the beginning of the openings of the lava tubes. Surprisingly, we have lava tubes also on the moon and on many other planets that have volcanism. We expect these things exist, including Mars. We expect the Mars and Moon have these lava tubes, so we can put our equipment actually there, being away from the radiation and being away from the harsh environment of the space. And actually, our future colonies on the Moon will be there. I will put a picture of those kind of lava tubes when the top of them actually is broken on the Moon. We can see that. But you can see all the lava is draining like a massive sinkhole into that lava tube, and some of it which the lava tube cannot take, flow over, and it gradually add to the surrounding environment, thickness of the wall, and the base and the foot of the volcano. This is an example of a lava tube on the Moon. We call them RILE, R-I-L-L-E, and some of them actually are the top of them has collapsed. You can see in the next image. This is that RILE. The top of it, or lava tube, has collapsed, and you can see even the debris is under it, under that hole, in the hole. Look at it. This is where we can actually place our stuff. I know that in America they have placed a lot of nuclear weapons and such things. They store them inside lava tubes. You can place a whole city there. Other countries probably have done the same. And this is how it is. You can see the lava tube in the lighter beige color, and the opening a skylight entrance there on top. And this is where the solidified lava has formed a tube kind of structure. In this image you can see is one of the real lava tubes on Earth. It probably is in Hawaii or in somewhere in Dakota, America. Anyway, or in Oregon and Colombia. This is another one of these lava tubes. You can see on the roof of it actually the cracks, desiccation cracks, where the thing has really got, the freezing of the lava. And here you see that the flood of the lava coming toward the people who are standing there doesn't come toward them, all sinks into the lava tubes. That's the reason they can stand there. Otherwise, this lava will flow toward them. They are not more than probably less than a kilometer away from that, and yet you can see that it's all sinking into the ground. Around 1 kilometer, around that, about that time, that dimension. Anyway, you can see here that the lava tube, oh God, look at it. It's like you can call it waterfall or lava fall or whatever you like. This is so amazing. Look at it. The size of this lava shedding. This is the size of the edge you can see. It's amazing. Never seen anything like that before. I've not seen. You may have seen. I have not seen. And this is where the lava ends up from the lava tubes. They're conducted toward the whatever is lower ground, and they can flow toward it. They gradually fill up the valleys and any cavity or anything there, make the landscape, covered completely in lava. Lower valley is now filling with the lava gradually, because the two walls, eastern and western wall, was breached. You can see the flood of the lava actually now going and covering all the area around, and that's what we are seeing. This is where the lava goes through the lava tubes, flows toward anywhere that is lower ground. Gravity pulls it down. It just goes down the slope, as you can see here in this example. It forms all kind of structures. When it solidifies, now we can see, call it name or Iceland kind of lava. We see the Ahoy, and the ropey lava, or as the name suggests, the sign of pain. They're very sharp sometimes. Those ones. Ahoy is like this ropey structure. Anyway, these are the vocabulary that we can use. And as you can see, this lava is flowing toward the lower ground, and it feels it's fast flowing. in a way. But in a way, because it's on a slope, people can get close to it. You can see in the next clip actually. People go close to it, put a hammer into it, geological hammer or anything. And the first person is a bit afraid, then later you realize that there's nothing to be afraid of.